Chapter 7. Continuous probability distributions. A random variable can take on values that are either discrete or continuous. This chapter has focused on continuous random variables where the potential values of the variable can be any value on a continuum. Examples of continuous random variables include the time it takes a worker to assemble a part, the weight of a potato, the distance it takes to stop a car once the brakes have been applied, and the volume of wastewater emitted from a food processing facility. Values of a continuous random variable are generally determined by measuring. One of the most frequently used continuous probability distributions is called the normal distribution. The normal probability distribution. The normal distribution is a symmetric, bell-shaped probability distribution. Half the probability lies to the right and half lies to the left of the mean. To find probabilities associated with a normal distribution, you will want to convert to a standard normal distribution by first converting values of the random variables to standardized z-values. The probabilities associated with a range of values for the random variable are found using the normal distribution table in the appendix or by using Excel. Other continuous probability distributions. Although the normal distribution is by far the most frequently used continuous probability distribution, two other continuous distributions are introduced in this section. These are the uniform distribution and the exponential distribution. With the uniform distribution, the probability over any interval is the same as any other interval of the same width. The probabilities for the uniform distribution are computed using the equation in the book. The exponential distribution is based on a single parameter, lambda, and is often used to describe random service times or the time between customer arrivals in waiting line applications. The probability over a range of values for an exponential distribution can be computed using the equation in the book or by using the exponential table in the appendix. Also, Excel and Minitab have functions for calculating the exponential probabilities. Conclusion. The normal distribution has wide application throughout the study of business statistics. You will be making use of the normal distribution in subsequent chapters. The normal distribution has very special properties. It is a symmetric, bell-shaped distribution. To find probabilities for a normal distribution, you will first standardize the distribution by converting values of the random variable to standardized z-values. Other continuous distributions introduced in this chapter are the exponential distribution and the uniform distribution. Figure in the book summarizes the discrete probability distributions introduced in Chapter 6 and the continuous probability distribution.